In this chapter, we're going to work on the forearm. There are a couple of different methods you can use for working out the twisting that's going to happen on these bones and of course the upper arm bones as well. One method is very simple and straightforward, and it's just using Max's constraint system. For this constraint system, what we're going to use is look at constraint on the first joint for the twisting. This bone here should rotate along the local x-axis 100% with the bone in the hand. First, what we're going to do is we're going to set up the hand so it actually rotates with the rest of with this control here. Easiest way to do that is it is currently linked to the end of the arm, and we're going to orientation constrain it to the control object so that it now rotates with the hand control. So when the hand control rotates through the x-axis, we want this first bone to rotate with it at a 1-to-1 ratio. We can't use wire parameters and we can't use reactor controllers for a couple of reasons. One, we can't wire to this bone because this bone isn't getting any translation change because it is orientation constrained to this. We can't wire to this object because it sits in the object space of this control here. And as the character started rotating and twisting and bending over, it wouldn't just be an x-axis anymore. In this case, it's never even an x-axis, directly one axis anyways. This object's rotating in this object space. So there's the axis of this object, which is along this axis right here. So it's not going to work either. We need to actually get the rotation of this joint along this axis here. So what we're going to do is a look at constraint on this first object. Constraints, look at constraint, we're going to make it look at the original arm elbow joint. This is going to flip this bone over, and I'm just going to say look at, select the look at axis, flip, and flip it back so it goes back into its correct spot. And then what I'm going to do is I'm going to set the up node, just like we did in the spinal column, but I'm going to set the up node to be the hand bone. So you can see what's happening now is that this bone is linked to the forearm bone. It's looking back at the forearm bone so that it stays orientationally aligned to it when the elbow bends, but its up node is using the hand bone. So now you have a situation where when the hand bone twists, the twist bone twists with it. To get the second one to twist a little less than this, 50% less than this, what we're going to do is we're going to use an orientation constraint. It is currently parented to the forearm bone, and I'm going to go to constraints, orientation constraint, constrain it to the twist bone in the first twist bone, and I'm going to constrain it to the forearm. If I had multiple more twist bones, if I had 3 or 4 in there, I would just use the weighting between the two to set it up so each one would twist off a little bit less. So this is a really simple and fast setup. You can see that when I twist this now, the twist bones are twisting down the length of the arm. So I'm going to wait a little bit to this one, and if we go back and turn on that the edit mesh, I'm going to wait between these 3 to get a little bit of twist. Now, I've created a problem for myself on purpose, and that's the range of motion that actually happens in the wrist. You can turn your wrist over about 180 degrees or somewhere abouts along the length of it, and everything appears to be working fine. What I'm going to do is I'm going to turn on in the bone tools the front fins so you can see the flipping happening. Side to side on a wrist, you can at best get to about 90 degrees if you're lucky. In a human hand, most of us can probably only go about 30 or 40 degrees either way. Everything seems to work fine there. Up and down, however, it's possible to actually get your hand to go past that 90-degree mark. It's flipping over. Again, this is due to how rotations work in 3D space. And this is in any piece of software. The general rule is that the middle axis of the three, XYZ, is the one that will flip at 90. The other two will flip at 180. So if we take a look at the local axis of this joint, Y is across because that's how we originally had set it up. We're going to fool this bone into believing that the rotation axis is different by playing with the source up node alignment. What the source node up node alignment will do will actually change the orientation of the bones to begin with. Aligned to up node axis, you can switch as well to flip it back. And if we play around with that, we should be able to get it to a point where up and down it no longer flips at 90. It flips at 180. But side to side, where we don't need the range, it will flip at 90. But that really doesn't matter again, because we're never going to get our hand to that kind of angle, especially one on this character where it's a huge wrist. It still doesn't flip on the twist along the axis until we pass the 180-degree mark. So we're okay on that one as well, because we're probably never going to get our hand past that point either. So to set that up again, it's just a matter of playing with the source axis to find the axis that's going to work, and then playing with the align to up node axis to get the bone back into the orientation that we want. We don't need to do anything with the orientation constrained bone because it's just directly orientation constrained between the two. We do have to make sure that this bone ends up back in the correct orientation though. And if you remember, if I'd left it the align to up node axis set like this, with this one in between partially, you'd say, oh well, so what? I mean, I'll just skin to it as it is. But the fact of the matter is what's going to happen is that you're going to reach a flip on this joint before you actually expect to, because it's trying to be constrained between this and this, and they aren't aligned together to each other. There's already a 90-degree axis change between this and this. So it's best to keep them set up and aligned correctly, so all their axes, all their local axes, are aligned in the same fashion when it's set up.